Hello. We are on, this is page 12, just right after the simplifying hack page. And this one is going to be decimal place value. Back to table of contents. I can find it. And this is important because place value is at the heart of number sense. And number sense is like common sense, but specific to math. So it's just being able to say, like, that answer could be right, or the ability to notice when an answer is definitely not right. When you're noticing it's way out, that's your number sense kicking in. And place value is at the heart of number sense. So one thing to know, if we start with the number, let's start with the number 123. This is going to be a review from days gone by. This is the ones place. This is the tens place. This is the hundreds place. And each place value, as we move from one spot to the next, is 10 times bigger. So the tens is 10 times bigger than the ones. The hundreds are 10 times bigger than the tens. We can also look at it the other way. I'm going to zoom in. That each time we go down a place value, it's 10 times smaller. So when we go from tens to ones, the tens are 10 times smaller than the ones. Okay, so there's always a difference though of a factor of 10. This is the same reason is why when we do something like exponential notation and we have 10 to the second power, we can use this to be the number of zeros. 10 to the second power equals 100. 10 to the fifth power means 5 zeros, which is 10,000. So these kind of pieces all work together. Another way that it works together is that if we take any number and we multiply it by 10, we're just moving one place value to the left, or moving up one place value. So an example would be 5 times 10 becomes 50, or 50 times 10 becomes 500. You can use this to figure out, okay, if I times something by 100, I'm moving up, instead of moving up one, I'm moving up 2 places. So like 5 times 100 moves 2 places. The 5 here moved 2 places up. We could go on, 1,000, 10,000, whatever. That's what you already know. I might have said it in words you haven't used before, but this is what you already know. And you probably already know some of this too. But with decimals, the place values continue to work the same way. So just like each place value gets 10 times smaller when we go this way, or 10 times bigger when we go this way, that doesn't change just because we add a decimal point. And the purpose of the decimal point is just so we can tell the difference in where things were smaller than 1 and then where they start to become whole numbers or bigger than 1. So let's take, let's say that I have a 4 right here. This place value, if I take my tenths and I times it by 10, I get my ones place. If I take the ones place and I divide it by 10, I get the tenths place. If I have 0.4 and I times it by 10, it moves up one place value to 4. Or if I have 0.4 times 100, it moves 2 places up. So instead of 4 ones, it's 4 in the tens. So the same system works. We're just stretching what we already knew about place value into decimals. So let's bring this into the places that you will need to know. So if we have the number 0.4567. I like to think of it like, well, I'll say that in a minute. Okay, so the first place value, this 4, is the tenths place. It's called the tenths place because it takes 10 of them to equal 1. So each one of these is 1/10 of a 1, of a whole. Next up we have hundredths. Make sure you're getting the on there. And that's because it takes 100 of these to make a 1. So it's the hundredths place. In the 6 area, we have 6 thousandths. Takes 1,000 things in this place value to make a 1. And we can go on forever. The place values continue to mimic whole number place values. They just have the on the end. So this would be the 10,000ths. It would take 10,000 of these pieces to make a 1 whole. So this number right here would be said out loud as 4,567 10,000ths. Oops, I'm gonna run out of room. And a lot of times you might hear teachers be kind of picky about how you say decimals. Partially that's because when you say something out loud, that's building your number sense. When you know how to say a decimal, you're thinking about the value. So that's why sometimes we're ornery about that. Okay, so that's decimal place value. This number, you've talked about expanded notation before. Or I'm trying to think of another word you might have heard. I can't think of another word. So for example, like the example from the last page, 123 in expanded notation is 100 plus 20 plus 3. And another example would be 348 would be 300 plus 40 plus 8. So you're just breaking down so each place value is separate. So I want you to try a couple of these on your own, and then I'm going to see in class tomorrow what you got for your answers. So I would like to start first with, we'll do an easy one, 123 and 4/10. So what would the expanded notation be of that? And 100, nope, just kidding. If we have 123 thousandths, what would that be? What would the expanded form of that be? So that's the end of this video, but there is one more to watch about addition and subtraction.